In this video, we'll go over Autosave to Excel. When saving to Excel, each piece of data in the memory list is saved to a separate worksheet that matches exactly with the memory list name. So if I autosave a curve called Fundamental, a new worksheet called Fundamental will be added to the Excel file. Excel must be installed on your computer. Cloud versions will not work. It also requires Windows. Saving to Excel is not supported on macOS. Templates can be used to specify a layout. We'll go over how to make a template and some use cases in this video. Macro-enabled files are supported. So here's our complete test sequence using AmpConnect. And at the bottom, I'm going to add a Save to Excel step. I'll select a couple of different curves here. With the Excel type selected, you can see there's a space to add in an Excel template, as well as some other options below. Enabling or disabling the axes will change what points of data are saved to Excel. For example, if I wanted to save phase, I would enable the Z-axis. You can switch the layout between rows and columns. You can change the header. We'll take a look at the standard header, or you can add in your custom or remove it entirely. Notation can switch between scientific and floating point. Decimal places affect both and affect the digits of precision. We can enable test information to tag that data into the specific workbooks. And we can change the file name just like we can with the SoundCheck format. I'll run the step and save it to Excel. And you can see Excel opens up in the background. I'll navigate to the folder location where the file was saved. And here's my Excel file. When I open it, you can see the workbooks are named for the pieces of data I have selected. I saved Fundamental, Harmonics 2 and 3, and the average sensitivity. On the left is the standard header. It tells you if the X, Y, and Z data is linear or log, and then it will list any units it knows. At the top, you can see the comment, serial number, operator, time, and lot number I specified to save in test information. This will show up on all workbooks. All the data is laid out in columns. If we switch to rows, the layout would switch from vertical to horizontal. Our notation is set to scientific with 2 digits of precision, so the Y and the Z data will go out to 2 decimal places. I'm going to remove all the test information and run the test a couple more times. When I open up the Excel file, you can see I've added on multiple runs in addition to our first run. I'll delete this Excel file so we just get a fresh one to work with. One way to clean up the data and make it a little bit easier to read when the x-axis is common is to disable the x-axis from the autosave. If we disable the x-axis, the first time the step saves, it will save the x-axis, but every additional run will only save the y and the z data. So with this disabled, I'll run the sequence a couple of times. When I open the Excel file, you can see the x-axis is saved in the A column, and then it's YZ, then the second run of Y and Z. Now let's look at creating a template for an Excel file with THD and rub and buzz, similar to what this graph is here. I'm going to change around the file name construction so every time this saves, it will be the sequence name, space, the serial number of the device. I'm going to add in an auto increment step, so every time the sequence runs, the serial number will increase by 1, and I'll get a new Excel file per run. I'm also interested in adding some test information, so I'll put that in here, and some results. I want to know if the rub and buzz passed or failed, and if the THD passed and failed. To do this, we'll need to create a second autosave step. The first autosave step is saving data, so the second one, we can save our results. We can save to the same Excel file though. So I'll choose the THD and rub and buzz margins, and I'll set the file name construction the exact same as the data autosave step. So here is serial number 3. I open it up and we have 4 different tabs: the THD and Rub and Buzz data, and then their margins. I chose the data I wanted to save, but how would I make a template to make this data a little bit more presentable? Appendix L in the SoundCheck manual goes over how to create an Excel template, and we'll work through that here. But the starting point is to select the data you want saved and run the step once. We've done that here, so we can use this to create our template. What we'll do next is create a new tab called Overall Report. This will point to the different tabs and give us an overall report of the data. Because we know that every time the curve named THD is saved, we can use that knowledge to point to different cells to gather information. So at the top I'll add the operator and the date. This will point to 2 cells that, because of how our step is configured, will always give us this information. Now I'll do the same for the THD and Rub and Buzz margins. When these pass or fail and we save it to Excel, this overall report tab will quickly show us if it passed or failed. The next piece of data will be graphs of the THD and Rub and Buzz curves. We'll select which cells have the X and the Y data in it, then plot them here. So this is everything that I want on my report tab. It's pretty simple, but you can make it much more complex depending on your needs. Now I'll save this in the report template folder with a unique name. And the last step is to clear the contents in all the SoundCheck generated data tabs. We don't want to delete anything, because that will break the cells that we're pointing to in our overall report tab. We just want to clear the data, so in subsequent sequence runs, new data will populate into these tabs. Once all 4 of these are cleared, I'll resave the template and go back to my autosave step. Now in both autosave steps, I'll point to the Excel file we just created. Now when I run the sequence, here's serial number 4. When we open it, we see the overall report tab has data that is filled from the most recent sequence run. Every time we now run the sequence with this template, it will give us this tab and have this data organized in the way that we selected. In the next video, we'll look at autosaving to MATLAB.